Okay, guys, 2.5, equations of lines and linear models. I want to start with a definition of linear equations in two variables with x and y. They represent a relationship in which the dependent variable, usually that's y, it depends on x, changes at a constant rate as the independent variable, which is usually our x, changes. Okay, so here's the situation. Since this is linear, we know it looks like a line. So if we look at this graph, and here's what I want to do is I want to pick a specific point on here. I'll call it x1, comma y1. So that's some specific point on line. And then I'll just pick some general point xy. That's just any point on the line. If I get that, we know for slope that I could write that as the rise, so that's the difference in the y's, over the run, the difference in the x's. Okay, so that's my slope. Notice we can rearrange this equation and we can get this. We can get m times x minus x1 is equal to y minus y sub 1. Okay, so all I did was I multiplied both sides by x minus x1. Now going down here to point slope form, the point slope form of the equation of the line with slope m passing through the point x1, y1 is, well, that same thing that I just wrote down. Okay, so why is that a form to write one of these linear equations in? Well, it's useful because here's our slope. X1, Y1 is any specific point you're given on the line. So this is handy when given one point and the slope. Okay, that's when this is useful. Okay. So for example, using this thing, it says find the equation of the line passing through negative 3, 1 with slope negative 2. So notice they've given me 1 point and the slope. So that makes me think, oh yeah, point slope formula. So I'm going to just write that down. Okay. So my 1 point is right here. So I know what x1 and y1 is. And here's my m. Okay. So that means I have y minus 1 equals negative 2 times x minus negative 3 or plus 3. Okay. Now that is the equation in point slope form. A lot of times, and we're going to talk about this in a minute, is we want in that y equals mx plus b form, that slope intercept form. But that's easy to do from here. If I just do a little bit of simplification, okay, so I get to right here, and then move the 1 over, I can get in probably what you're more familiar with, the slope intercept form. That means that y is equal to negative 2x minus 5. Okay, so that's your slope intercept form. But at least we see that point slope form was handy to get this thing set up. Okay, so speaking of slope intercept form, that's the second form we're going to talk about that we can have these linear equations in. The slope-intercept form of the equation of the line with slope m and y-intercept b is y equals mx plus b. What's nice about this is if it's in this form, we know the slope and we know the y-intercept. Okay? So let's see how this works. It says write the slope-intercept form of the equation of the line with slope 3 over 4. Okay? So right there, I know that m is 3 over 4, and y-intercept is 0, negative 2. So this is like 0, comma b. So I know b as well is negative 2. And I want in slope-intercept form, I can literally just write down the answer in this case. Y equals 3 over 4x minus 2. If I graph that, I'll start here at 0, negative 2, and my slope tells me to go up 3, 1, 2, 3, and it tells me to go over 4, 1, 2, 3, 4. That's going to be the point 4, comma 1. Okay, so I got 2 points. This is linear, so I have a line, and there's my graph. If I look at B, okay, write the slope-intercept form of the equation of the line through 2, 3, and negative 1, 2 in slope-intercept form. There's a few different ways you can do this, but I'm going to start with the y equals mx plus b. Now, I know that I can find m like this from the last section. M is x2 minus x, nope, not x's, I'm sorry, y2 minus y1, the change in the y, the change in the vertical part, over x2 minus x1. Whatever I get there, I can plug in for m, okay? B I can find after. I'll show you how to do that. But if I look at this, I guess I'll call this my x2, y2, x1, y1. So I'm going to get y2 minus y1 over x2 minus x1. That's really 2 plus 1. That's going to be 1 over 3. So right here, 1 over 3, that's m. So I know my equation in slope-intercept form is y equals 1/3 x plus b. But I'm not done because I don't know b. Well, here's the thing. Whatever b is, it has to make this equation true for 2, 3, and -1, 2. So I can choose either one of those, plug them in for x and y, and determine b. Okay? So I think what's probably going to be easier is I'll use -1, 2. Okay? So that means 2 is equal to 1/3 times -1 plus b. 2 equals -1/3 plus b. Add 1/3 to both sides, and I'm going to get 7/3 is equal to b. So now that I have b, I'm just going to plug it right back in up here. So everything together, y equals 1/3 x plus 7/3. That's the equation of this line in slope-intercept form. Okay. And to graph it, I can go ahead and I can put in my 7/3 and use all these fractions, but instead of using all the fractions, I have 2 points anyway, so it's very easy to graph. I could have actually done that right off the bat. I got 2, 3, and I got -1, 2. 2 points, determine a line. And of course, you always have your graphing calculator as well. All right, that does it for the first video for this section.